S3, S4 Physics, Resistance Circuits. Resistance is futile. You will be trained. Can't avoid a good Star Wars joke. Resistance circuits. In S1, you learned the definition of resistance as the opposition to the flow of current. This means that the greater the resistance in the circuit, the lower the current, and the lower the resistance, the greater the current. Let's look at resistance circuits in series. When resistors are connected in series, the total resistance is always greater than the value of the greatest resistance, and that's because the resistance always increases as you add extra resistors. So here we have resistors connected in series, so we can say if R1 is equal to 4 ohms, R2 is equal to 5 ohms, and R3 is equal to 9 ohms, the total resistance will be greater than 9 ohms. In actuality, the total resistance here is going to be the sum of all of those values. It's going to be 18 ohms. So for practical work or research, it can be shown that for resistors in series, the total resistance RT can be calculated from RT is equal to R1 plus R2 plus R3 and so on and so forth. And this relationship is on the relationship sheet. Example, calculate the total resistance in the following circuit. We have two resistors in this circuit, 8 ohms and 24 ohms, connected in series. So we should be expecting the answer is going to be greater than the largest resistance, that is greater than 24. We use the equation RT equals R1 plus R2 equal to 8 plus 24, which gives us 32 ohms, greater than 24, as we'd expect. But this is a special case. When all the resistors connected in series have the same value of total resistance, the resistance value then can be multiplied by the number of resistors. So here I've got 3 resistors. If each of these resistors have exactly the same value of resistance, then I can say that the total resistance is 3 times the value of one of the resistors. So if the resistors in the above circuit all have a value of 7, the total resistance would be 7 times 3, which is 21 ohms. And we'll see there's a similar rule for parallel. Resistance circuits parallel. When resistors are connected in parallel, the total resistance always decreases as you add extra resistors, which means that the total resistance is always less than the smallest resistance value. And this is because if we have a look at this diagram where the resistors connected in parallel, we're actually adding additional paths for current to flow. If we have additional paths for current to flow, the total current is going to increase. Therefore, the total resistance must have decreased. So in this example, if R1 is equal to 4, R2 equal to 5, R3 equal to 9, and R4 equal to 12 ohms, we know that the total resistance must be less than 4 ohms, because the total resistance in a parallel circuit is always less than the lowest value resistor. So from practical work or from research, it can be shown that for resistors in parallel, the total resistance RT can be calculated from the following equation. 1 over RT is equal to 1 over R1 plus 1 over R2 and so on and so forth. And again, this relationship is on the relationship sheet. So in this example, we're asked to calculate the total resistance of the following circuit. We have an 8 ohm resistor connected to a 24 ohm resistor in parallel. So automatically we should be thinking that the total resistance is going to be less than 8 ohms because the total resistance in a parallel circuit is less than the lowest resistor. We use the relationship 1 over RT is equal to 1 over R1 plus 1 over R2, giving us 1 over RT is equal to 1 over 8 plus 1 over 24. Now there's a number of ways to complete this calculation. We're going to look at the different ways across the slides. Method 1, using your calculator. So we can add the fractions on the right hand side of the equation on your calculator. Your calculator is likely to display one of the following. For example, 0.166666666 but all of these represent 1 over RT. We need to turn these numbers upside down. So 1 over RT is equal to 0.166. So RT is equal to 6 ohms. And that's because 1 over 0.1666 and so on is equal to 6. Method 2, we can use decimals. So we change the number on the right hand side to decimals and then add them up together. But we have to be very careful of rounding here. So 1 over RT becomes 1 over 8, which is 0.125, plus 1 over 24, which is 0.0416666666. This equals the same values we had before, which then we need to turn upside down and say RT is equal to 1 over 0.1666666, which is equal to 6 ohms. Now, both of these methods can be a little bit messy. They depend on you not rounding wrong, not rounding too soon. So another way which you might find a little bit simpler is by taking the resistance and using fractions. Now, your calculator, scientific calculators, have the ability for you to add fractions on the calculator. And if you add those fractions together, you will get the same results as doing this. But it's very useful to use your mental mathematics. And the examples which are in the multiple choice section of National 5 examinations and National 5 assessments are all fairly straightforward and should be straightforward for you to use your mental maths. So we get 1 over RT is equal to 3 over 24 plus 1 over 24. And that's because 1 over 8 multiplied by 3 top bottom is equal to 3 over 24. So 3 over 24 is the equivalent fraction of 1 over 8. Now, because we both have these with the same denominator, we can just add the top lines. So 1 over RT is equal to 4 over 24, and then we flip. If 1 over RT is equal to 4 over 24, RT, or RT over 1, is equal to 24 divided by 4, which is equal to 6 ohms. Quite often, people find method 3, the fractional method, the simplest way to solve resistance circuits in parallel. As with series circuits, there is a special case. So when all the resistors connected in parallel have the same value, the total resistance is that resistance value divided by the number of resistors. So we have a look here, we have 4 resistors. Each of the resistors have the same value. So the total resistance is going to be that value divided by 4. So if we said if all the resistors in the above circuit had a value of 60 ohms, the total resistance would be 60 divided by 4. If I had 6 resistors of 60 ohms, then the total resistance would be 60 divided by 6, which would be 10 ohms. Which again follows the rule in that we know that as we add resistors in parallel, we are reducing the overall resistance. Quite often we find that resistance circuits are mixed, and that's where we use a combination of series and parallel elements. So in this example circuit, we can see we have a series element, that's P and Q in series here, but then we have a resistance R connected in parallel, and we also have a resistance S connected in series with this overall parallel combination. So it can look a little bit messy, but what we can do is we can try and simplify. It's always best to find the parallel resistance value first and then add it to the series value. It stops you. Example. In the following circuit, find the total resistance between W and X. So the first thing we're going to do here is we're going to find the parallel combination between Y and Z. Because once we've done that, we can then add the resistance here, 6 ohms, because it's in series. And that will give us a total resistance between W and X. So here's our solution. 1 over RT is equal to 1 over R1 plus 1 over R2. 1 over RT is equal to 1 over 2 plus 1 over 4. You can pick your preferred method in order to solve this. I would normally go for the fractional method. 1 over 2 is equal to 2 over 4. And then we have 1 over 2 plus 1 over 4 equaling 2 over 4 plus 1 over 4, which is 3 over 4. Remember, this is still 1 over RT. So in order to find RT, we need to flip, and RT becomes 4 over 3, which is equal to 1.3 ohms. Remember, this is the parallel resistance. This is the resistance between Y and Z. So in order to find the total resistance between W and X, we need to take that parallel resistance and add it to 6 ohms, giving us a total value of 7.3 ohms. Review questions. Calculate the total resistance in the following circuit. Well, we see that this is a series circuit, so we're going to use the rule RT is equal to R1 plus R2, which is equal to 2 plus 3, which is 5 ohms. Calculate the total resistance in the following circuit. So we have a parallel circuit now, so we're using the rule 1 over RT is equal to 1 over R1 plus 1 over R2, which is equal to 1 over 60 plus 1 over 30. I'm going to take 60 as my common denominator and say this is equal to 1 over 60 plus 2 over 60. 1 over RT is equal to 3 over 60. Remember to flip, so RT is equal to 60 divided by 3, which is 20 ohms. As we'd expect, the value of the total resistance is less than the value of the lowest resistor. Question 3, calculate the total resistance in the following circuit. We have a mixed circuit here, so the first thing we want to do is calculate the parallel element, so that's these ones. So 1 over RT is equal to 1 over R1 plus 1 over R2 is equal to 1 over 10 plus 1 over 20. We'll take 20 as the common denominator, so 2 over 20 plus 1 over 20, which is equal to 3 over 20. And this number is not going to be as nice. Remember, we need to flip. So 1 over RT is equal to 3 over 20. So RT is equal to 20 divided by 3. So we're going to have to do some rounding here. 20 divided by 3 rounds to 6.7. We then add that to our series, 5 ohms. RT is equal to R1 plus R2, which is equal to 6.7 plus 5, giving us 11.7 ohms, which we could round to 12 ohms. Question 4. Calculate the total resistance in the following circuit. It's upside down, but that's still a series circuit. So our total resistance, RT, is equal to R1 plus R2, 4 plus 2, equal to 6 ohms. Calculate the total resistance in the following circuit if the lamps have resistance values of 15 and 35. So we're going to use our parallel combination here. 1 over RT is equal to 1 over 15 plus 1 over 35. Now this one's a little bit more tricky to carry out. So what we might want to do is use method 1 or 2, where we're working things out as a decimal. Or we could add the fractions on our calculator, which you may find to be a little bit more simple. If you add those fractions on your calculator, you end up with 2 over 21. If 1 over RT is equal to 2 over 21, RT is equal to 21 divided by 2, which is 10.5 ohms. Calculate the total resistance in the following circuit. Again, it's a mixed circuit, so we want to work out the parallel combination first. But here, look, here's a special case. 720 ohms and 720 ohms. These resistors both have the same value, so that means I don't need to do the calculation because the total resistance is going to be that resistance divided by the number of resistors. 720 divided by 2. So 720 divided by 2 is 360. So our total resistance is equal to 360 plus 120, which gives us 480 ohms. Here's your answers for review, in case you did the questions yourself. And now past paper question. Now we're going to do quite a few examples of the past paper questions because this is very, very common within the National 5 course. So first of all, let's have a look. In which resistor is the current the smallest? So we're looking at our definition of resistance here first. Remember our current rule, the current is the same in a series circuit. So the same current is going here as is going here. So that current is going to split between these two. 5 ohms, 50 ohms. That same current is going to go through 100 ohms and it's going to split between 20 ohms and 10 ohms. So how do we figure that out? Well, the current value is going to be the smallest where we have the largest resistance. This parallel combination tells us that our total resistance is going to be less than 5. This total combination tells us our total resistance is going to be less than 10. So the largest resistance is 100 ohms. So that's our answer. E. Okay, so here we have another parallel combination. Remember our parallel rule, 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3, which is 1 over 8 plus 1 over 8 plus 1 over 4. We're going to take 8 as our common denominator here. So that's 1 over 8 plus 1 over 8 plus 2 over 8, giving us 4 over 8. 1 over RT is equal to 4 over 8. We must remember to flip. So RT is equal to 8 divided by 4, which is 2 ohms. We have a check here. We expect the total resistance to be less than the lowest resistance. Lowest resistance is 4. So even if we hadn't done the calculation, immediately we could say that E is going to be wrong and D is going to be wrong because those resistances are too big. In actuality, our answer is 2 ohms, so that is C. So we have another mixed circuit here. However, we can see that these resistors have the same value. So remember the special case. If we have resistors connected in parallel of the same value, the total resistance is equal to the value of the resistor divided by the number of resistors, in this case 2. So 4 divided by 2 is equal to 2, and then we use the series circuit rule. RT is equal to R1 plus R2, which is 4 plus 2 equals 6 ohms. That is C. So another parallel combination. Now you find the more of these you do, the better you get at it, the quicker you get at it. 1 over RT is equal to 1 over R1 plus 1 over R2, which is equal to 1 over 8 plus 1 over 24. Take 24 as our common denominator. 3 over 24 plus 1 over 24, which is equal to 4 over 24. Remember, we need to flip it. So RT is equal to 24 divided by 4, which is equal to 6 ohms, which is C. Students set up the following circuit, calculate the current in the circuit. So we can see this question here is worth 4 marks. Now 4 marks immediately tells you there's 3 marks for the calculation and 1 bit of extra thinking. In this case, the extra bit of thinking is to find the total resistance. RT is equal to R1 plus R2 plus R3. Very simple mathematics. We're only going to get 1 mark for this. 30 plus 30 plus 15 gives us a total resistance of 75 ohms. Then we're using Ohm's law. I is equal to V over R. 15 divided by 75. We could work this out in our heads because 15 goes into 75 5 times, same as 1/5, which is 0.2 amperes. 1 mark for the resistance, 3 marks for this. See if you don't work out that total resistance first. You only get 1 mark for the correct equation here using Ohm's law. So you've got to be very careful. Next one. From the previous circuit, calculate potential difference across resistor R1. This is resistance. This is Ohm's law. This is circuit rules. All of these things combined. Now remember, from the previous question, we said that I, the current, which is the same at all points because it's a series circuit, is equal to 0.2 amperes. Resistance R1 is equal to 15 ohms. And we want to find V1, the voltage across it. So V is equal to IR is equal to 0.2, or 1/5, multiplied by 15. 1/5 of 15 is 3 volts. Same again. This time I want to calculate power. So what do I know? I know that the current is equal to 0.2 amperes. I know that the resistance is equal to 15 ohms. And in a previous question, I worked out the voltage as well. I worked out the voltage to be 3 volts. So I could use any of the power equations here. Here are our power equations. P is equal to IV, P is equal to V squared over R, and P is equal to I squared R. Now I'm going to say that I'm probably most confident with the current value, so I'm going to use that in my calculation. So I'm going to say P is equal to IV. 0.2 amperes multiplied by 3 volts gives 0.6 volts. But just for argument's sake, let's try another one. Let's go for P is equal to I squared R. 0.2 squared multiplied by 15, which is 0.04 multiplied by 15, which is also equal to 0.6 watts. All of them would give you the exact same answer. State how the reading on the ammeter compares to your answer in part A if the circuit is now rearranged. Now in A part 1, remember we saw the current was equal to 0.2 amperes. We're now combining the resistances in parallel and series as well as just in series. Remember, if we combine resistance in parallel, we reduce the overall resistance. So if we reduce the overall resistance, RT goes down. That means, therefore, current must go up. Now it says to justify your answer by calculation. So this isn't enough. We need to show the calculation. We've got 30 and 30 in parallel there. Special case. So the total resistance here is going to be 30 divided by 2. So our total resistance is going to be equal to 15 plus 15, which is 30 ohms. We then work out our new current. I is equal to V over R, 15 divided by 30, which is equal to 0.5 amperes. So 5 marks. Why 5 marks? Well, you get the marks because you're having to calculate a new resistance. You're having to do a new calculation here, and you need to say that the current has increased.